Hello everyone, let's solve this problem. In this problem, we have to find r dot, theta dot, r double dot and theta double dot. When we read this problem, it is very clear for us that this problem is related with r and theta coordinate system. And this type of problems are always very easy because you have to make vector diagram and then you have to use formula from r and theta coordinate system. So basically when we have to solve this problem, I always suggest to my student that write all information on your notebook and also make a table like the values for r dot and r double dot, and similarly for theta, theta dot and theta double dot. Whatever information you have, you can write. The next step is to make vector diagram. It is very important to make a correct vector diagram. Any minor mistake will result in wrong answer. So here I am drawing the vector diagram, the first x and y axis, then there is r, same as per our problem, and I am making a vector in purple color. It is 30 degree with the horizontal line, and on the downwards direction it is 15 degree. As you know that any vector will have two components. So this is r and theta coordinate system problem. So I will try first to make coordinate in r and theta. From this picture, it is very clear that r is shown here. We need to make a theta coordinate. Theta coordinate is always perpendicular to the r line. And note that r is always positive when you go outward. When you go far away from origin, it is plus. And theta is positive in the direction of the motion. So you can see that purple vector on the left side. So that's why I made plus theta direction. This vector will have two components in r and theta coordinate system. So I made v theta and vr, two components. Angle is given as per the problem, so I'm not making any calculation. I'm just writing all details from the problem, that is 30 degree and 15 degree. And I also wrote 80 meter on the x-axis and on the y-axis. So you can see that the point P is equal distance in x and y direction, so you can easily calculate r. So I'm going to write the initial values for the vector v. It is given 100 meter per second. R can be easily calculated. Why? Because it has 80 meter on the x-axis and on the y-axis it is 80 meter. So you can take under root and you can calculate the distance. O to P is r. Now we will use the formula from r and theta coordinate system. As I said, r and theta coordinate systems problems are very easy because it is all dependent upon on a correct vector diagram and on the formula. So you have to rewrite the formula Vr, or the vector component in r direction is r dot. Now you have to go back to the diagram, the vector diagram, and you can see that Vr component can be written as V cos 15. So I will just put the values here. V is equal to minus 100 cos 15. Why it is negative, guys? The reason for negative is that VR is moving in opposite direction of R. As I said, if you go far away from O, I mean O to P direction, upward direction, it is positive. So here you can see that VR is moving in downward direction. So we wrote minus VR. So we have just calculated R dot from this formula, and as you know that this V has, the vector has two component, VR plus V theta. I just wrote this equation just for your information, although there is no such need for this. Now we will move to the next formula for V theta here, and we will utilize the vector diagram to also calculate the value for theta dot. So you know that V theta is R theta dot. This is from the standard formula from R and theta coordinate system. So here, if you go back, you will see in the diagram, vector diagram, that V theta is exactly V sine 15. So I will write here simply the value for V 100 multiplied by sine 15. And this is a positive quantity because you will see that the motion of the V theta or direction of V theta vector is in the positive theta axis. So from this formula now you can easily calculate the value for theta dot. So the value for theta dot is 0.229 radian per second. Let me remind you that if you put 1 time theta dot, it means we are taking 1 time derivative of it. It means d theta upon dt. So that's why we wrote radian per second. And unit is always radian per second for theta dot, although when we have to calculate the components, we use the angle in degrees. So now we have received the value for theta dot. Now our next objective is to find r double dot and theta double dot. It means 2 times differentiation of r and theta with respect to time. And these are the acceleration quantities. So we will go back again to the r and theta formula sheet, where you will see there are 2 formula for acceleration. Basically, these are 2 components of the acceleration. One acceleration component is AR in radial direction, and another component theta in theta direction. So you can write A is equal to AR plus A theta. I am talking about the vector terms. Now let's move and write full formula for the AR, acceleration in the radial direction. This formula is visible on the screen, r double dot minus r theta dot square is 0. Now why it is 0? Why I wrote 0? Can you think about it? The answer is in the problem itself. When you will read this problem, you will find that they are talking about the constant speed. When there is a constant speed, it means there is no acceleration. And when there is no acceleration, it means both components are zero. So I can write here AR is equal to 0. Please note that in some r and theta problems, accelerations are present, and in that case, you have to also make acceleration vector diagram. But in this problem, there is an acceleration is 0 and speed is constant. So we are not making any diagram for AR and A theta. So I wrote here also for A theta is also 0, and we can also write in vector terms A is equal to AR plus A theta. This is just for the information. There is no need for this equation again here. So let's solve for AR. In that case, you can see that r double dot minus r theta dot square is equal to 0. In this equation, we know the value for r, we know the value for theta dot. The only unknown in this equation is r double dot. So you can easily calculate the value for r double dot. So I will write the value for r is 113.1 multiplied by theta dot value, and it is a square, so 0.229 square. So r double dot will be 5.92 meter per second square. Now sometime students confuse with the units of r double dot or r dot and theta double dot. I will tell you that r dot is always in meter per second, r double dot is always in meter per second square, and when we write theta dot, it is radian per second, and theta double dot is in radian per second square. So these are the general information. Let's see again. We are moving to calculate A theta, and I wrote the formula here. And in this formula, again, you will see that theta double dot is unknown. So simply you have to put all values and you will get the answer for theta double dot. And what will be the unit for theta double dot? It will be radian per second square. Please also note that r dot and theta dot are calculated from velocity formula, and theta double dot and r double dot, these entities are calculated from acceleration formula. So till now we have calculated all values of this table. I mean r dot, r double dot, theta dot, theta dot, and theta double dot. So we have calculated everything in this problem. Let me give you some quick tips for r and theta problems. The first step in r and theta problems is to make a table like this on the screen for r and theta. The second step is to put all values whatever given in the problem and mind what information you have to calculate. The second important step is vector diagram. Make a correct vector diagram. Please do not make any minor mistake. Make sure that you choose the axes very carefully, okay? And based on this vector diagram, use the formula and try to find r dot, r double dot, theta, theta dot, theta double dot. So r dot and theta dot is basically calculated from the velocity formula. And just another reminder that r double dot and theta double dot is calculated from the acceleration formula. When you are choosing the axis like r and theta, make sure that you are not making any mistake. For example, suppose this is a r axis. R axis is positive when we are going outward direction, in the direction of the red arrow you can see. And theta axis is always perpendicular to the r line, but when it will be positive, you have to see the motion of the vector. So if vector is going in upward direction or in this quadrant, it will be positive. If vector is on the right side quadrant, it will be negative. Please don't forget to like and subscribe. Thank you very much.